Hello everyone, thanks for coming and welcome to this presentation about fast prototyping with RISC-V Microcontrollers. My name is Giancarlo Parodi, I'm application and marketing engineer at Renesas, and today we're going to go through this interesting topic, looking at some of the typical challenges that you might encounter when starting a new development on RISC-V at this application level, and how to overcome those. This is the agenda, quickly. Quick overview about RISC-V at a glance, and then we'll go through some information coming from an embedded market survey done last year about challenges when developing embedded systems, and then how we can manage to break those ecosystem barriers using the support and the Renesas environment. And then we go through some details about fast prototyping board that is a topic for today, and the summary at the end. So on this slide you might already be familiar with. Basically it's just a recall about the state of the union on RISC-V. All of these different statistics might be not most up-to-date in some case, but it's clearly visible that the trend of RISC-V is adopting now more and more industries and segments and application types. The member community is growing exponentially year over year, and new designs tend to incorporate more and more RISC-V processors, whether it's at main CPU level or coprocessors, accelerators, and so on. And this is indeed a disruptive technology, so it breaks with the legacy ISA past. It has many points of strength, native strength, that make the implementation particularly efficient and optimized. But there are also some issues that are typically related to a growing ecosystem. So, and that is what needs to be worked on. So let's look now at some of the developers' challenges that were identified by this market survey. First of all, most of the new projects involve incremental designs. So existing designs get modified to add software features, to replace the current processor with a most powerful one, or with one that have additional features. And the main areas identified are quite broad, but range from industrial automation, IoT, communications, and automotive, just to start listing them from top to bottom from the application area. And 1/3 of all these applications is somehow related directly or indirectly to IoT applications, so networking applications for sensor-driven industrial or mobile communication applications. C language is very dominating still, and actually the comment about improving the debugging process was the first listed design challenge in this survey. So users could simply choose among different topics which one is the most relevant to them. And using development boards is very popular, very widespread, and surprisingly Raspberry Pi and Arduino seems to have quite a strong foothold for proof of concept design, and the rest obviously is using either own developed boards or proprietary boards. I assume this means coming from the semiconductor supplier itself. And among those designs where the processor was changed, half of it switched to a different family or a different architecture or a different instruction set. And below on the bottom left side, there are listed the main reasons why the processors were switched. So some of them are obvious. The new one has better features, or the previous one got too slow, so the performance was not enough. But interesting enough, the purple box highlights the fact that either the previous processor was end of life, so no more available, or the new one had a more appealing roadmap. And particularly interesting is also the last point. I mean, the list is much longer, but this is just from top to bottom. The new processor was better supported by software and tools. So here we already get a little bit of a hint where the problem might be. This slide here shows the topics about what is what is most relevant to embedded developers when starting new projects, or what are the key factors to consider. So obviously meeting the application performance requirements, otherwise the processor is not usable for the application task. Very interestingly, on the top, the 2nd, 2nd and 3rd high feedback were about debugging process, testing and integration. So it looks like that is really a key concern for developers, even more than having meeting schedules or processor cost. Now on this slide, we look about the factors that people considered when weighing in what is most important to them for choosing a device. So first point is the ecosystem is really playing a dominant role. In fact, if you look at the top 2 topics, chip performance, IOs and peripherals, is also kind of obvious. So to implement your system, you need to have the interfaces that you need, and you need to be able to achieve the performance that is required. But all the one in the green box are related to ecosystem topics. So either you're concerned about availability of compilers, debuggers, or the support for the debug by the processor itself, or the ecosystem in terms of RTOS, tools, support by the manufacturer. Then looking at the past, the software that is already available for it, so existing code, drivers, middleware, and the hardware tools. So not only emulators and scopes, but also kits, development kits. The choices made in terms of architecture when weighting a processor selection tend to be sticky, and that is interesting looking at the bottom where the red arrow is. So the familiarity with the architecture and the chip family is weighted as an important factor. And this also is a hint that it might be perceived as a potential barrier when, for example, you want to switch from a legacy or mainstream architecture to RISC-V, which is maybe fairly new to you. And last but not least, the purple box highlights another issue which is maybe more related to sourcing and availability of the ecosystem and the samples, because it's about the supplier's reputation. So whom am I sourcing my products from? Is it a renowned supplier? Is it a no-name supplier? Is it a newcomer? Are there any business risk related? And the family roadmap. So what is the chip's future? Have I good confidence that this device will be available for a reasonable long time and there will be follow-up versions? So broad commercial support and sourcing are important. Now let's look at how we can solve these challenges. So to support the RISC-V growth, we said the ecosystem is key. And in this case, Renesas is very well engaged in developing the RISC-V ecosystem. So we provide a free of charge development environment with integrated tool chains and also programming tools to support your application development. We also added support for commercial development environment, debuggers, production programmers, and we have in our roadmap also further expansion of this solution. So the chance that your developer environment of choice will be supported is even higher. We have to ease the migration, so make it easy for people to move to RISC-V if they want to. So we have to crush these adoption barriers that exist, not because RISC-V is bad, but because it's a growing ecosystem. So the low-cost development kits like a FPV board that we are going to give away today are worldwide available, low cost. And also globally you can get samples of the devices. You have application notes available to start your application development, and also support from Renesas, from the supplier. More to that, for configuring the chip, the IOs, the clocks, all the peripherals, and generating the peripheral low-level drivers, we have a code generation tool that basically can abstract all of these specific architectural details you might not be so familiar with when you start with RISC-V, and help you focus on the application development. So basically this helps establishing RISC-V as really the open platform for the next generation solutions that are non-proprietary. And finally, about the topic of reliable sourcing, Renesas is a renowned supplier. Therefore, we lead the market with innovation, and we are ready to support the RISC-V momentum. And we are demonstrating that it's possible to deploy RISC-V commercial products with excellent quality and excellent support from the supplier. And therefore can help you expanding within our portfolio your migration maybe from 8 or 16-bit legacy architectures to a modern 32-bit architecture that is high performance and at the same time is keeping the cost down. This is a quick overview of the device that is being launched in this first group of microcontrollers and is embedded on this board. So it has few highlights here in red. So it can support a very high temperature operation up to 1 to 5 degrees. It has a very broad voltage range support from 1.6 to 5 volts operating. It embeds Renesas' own CPU design. This is also new. The availability of this CPU was announced in November last year, and this is the first product that embeds it. If we look at the peripheral mix, it's very attractive for mixed signals applications because it has quite a strong and broad support for analog interfacing, but also for connectivity. It has a lot of safety features that help build in strong reliability into your application, has few protection options to make sure that your IP, your intellectual IP, is protected from unauthorized copying, and also at the same time it makes updates in the field robust, and is delivered in quite a big variety of packages, so QFN from 48 to 24 pin, and also in a very small wafer level chip scale package 16 pin. And this is the development environment that you can use to develop applications. So looking at the left-hand side from the debugger support, we have support for our own debuggers, so the Renesas E2 and E2 Lite, and also for Sega J-Link, which is a very, very popular and market-leading debugger. From the development environment perspective, there are also several options. On top, we have Renesas E2 Studio, which is a free of charge Eclipse-based IDE from Renesas that you can download freely and use. And also, we support for this device Sega Embedded Studio and IR Embedded Workbench, which are exceptional commercial level development environment you might be already familiar with. So that provides you also a pass from your environment perspective. Compiler-wise, we deployed an LLVM-based open source compiler that you can also use and download for free, and that is integrated in E2 Studio. So if you download the package with the support for this device, you will get the compiler also included. And obviously, the commercial IDEs have their own optimized high-performance compilers and linkers that you can use for your projects. The second last column is about support plugins. So to avoid the blank page syndrome you might have, so where do I start now to configure my application, to start writing code, we have a plugin integrated into E2 Studio, which is called Smart Configurator. And with this plugin, you can basically set up everything from low-level IOs up to clocks, system-level settings, configure the peripherals that you need to use, and also auto-generate the drivers. So basically, everything below the hardware abstraction layer is already available for you with a few clicks. And more to that, to enable the same user experience also on the commercial environments, this plugin is available as a standalone version. So in theory, for example, you can start evaluating free of charge with the whole E2 Studio environment, and then later on, if you decide to move to a commercial environment, you can use the same code configuration and project generation plugin also on these two commercial options. And finally, the evaluation kit. That's our nice tiny little board, the fast prototyping board, which includes a Sega J-Link onboard debugger. So basically, the only thing that you need to start a project is a USB cable and your PC, nothing else. And we also support production programmers, both software and hardware versions. So this is a close-up of the board. It's very small, it's almost a credit card size format. And here below you have the direct links to the website where all the information is included, so schematics, quick start guide, even the Gerber files. So if you want to do your own board, you can reuse this design as you want and simply modify it. So now let's have a look at what is available. Starting with the MCU, of course, that's the heart of it, and that's a 48 MHz, 1 to 8 kilobyte flash version. It has 16 kilobyte of RAM and 4 kilobyte of data flash. This is basically usable similarly to an EEPROM, so it's essentially an on-chip EEPROM that you can use for data, and is a 48QFN package. The board is powered directly by the USB-C interface connector, or if you want, you can also use an external supply if you wish. If you want to test the environment at a different voltage level, you remember it can go from 1.6 to 5 volt. That on the top right is the J-Link onboard debugger, which is integrated, and also has a nice, interesting feature of a virtual COM channel. So when you connect the USB-C to your PC, you also see a virtual terminal appearing in your environment, and you can use that as a console or for a debug output, for example, to test your application. There is a user button, a reset button, 2 LEDs for quick visual feedback. And then on top and the bottom, you can see Arduino connectors in the UNO R3 format. So if you have already shields that you want to plug in on top to extend the board with additional sensors, displays, interfacing modules, you name it, you can do it very easily and quickly. Plus, there are 2 Digilent P-Mod connectors. P-Mod is a kind of standard from Digilent. So on the market, you find also plenty of plug-in modules, very easy and simple to use, that you can simply connect to extend the functionality of the board. Finally, there is also a footprint for a Grove connector. So you have any seed system boards, you can connect them as well. And also a footprint for an IR remote control receiver. So you can even do a remote control of the board if you want. There is also a footprint later. There will be also directly a connector to be able to choose either the Renesas E2 Lite or a third-party debugger, which is also possible. And finally, the breakout connectors for the MCU. So if you don't have any shield that fits, so you don't want to use P-Mods, but you want to build your own daughter card or simply make some measurements, etc. All of these connections are basically breaking out the MCU pins. So you have full availability of the interfaces even on this area. And lastly, since this is a device suitable for battery operation, low power application, etc., you have also a pin where you can do current measurements at runtime. Good. So it's time to get a summary and shortly to get your board. So please, let's go through the last slide. First of all, one message: Renesas is leading the market and is ready for RISC-V. So we have high quality and support to ensure your commercial success with those devices. And this MCU is really an ideal choice if you want to be one of the market leaders that is valuing non-proprietary instruction set architectures like RISC-V. These are efficient devices, so enable you to develop versatile applications that are energy efficient and innovative. And the balance of analog and digital interfaces, IOs, allow you to have cost down, so cost advantages due to this high peripheral integration, even on such a tiny device. And most important, the development is easy, it's low cost, because we have a very, very broad tool support, and this can reduce your time to market. So if you want, you can quick start today by using the free of charge Renesas provided environment at your choice. Or you can also already use commercial environments from industry tool leaders like IR or Sega, and the ecosystem is growing, so stay tuned for the next steps. And the low-cost board gives you a pleasuring, out-of-the-box experience because it has everything you need to start a project. So with this, I would like to say thank you for joining. Thank you for joining so much. Please make sure you get your badge scanned at the front desk so you can get your board for free. I hope you enjoyed the presentation, and I hope you will have lots of fun and very good enlightening ideas when using this board. Thank you very much.